Hello everyone, Assalamu alaikum. This is Hamza Ali, and today I will present deep learning approaches for animal classification. And this presentation present to Dr. Professor Dr. Shahram Tahir. Let's start. First of all, we will discuss about approaches with KNN. What is KNN? The K nearest neighborhood KNN algorithm is a supervised machine learning algorithm that can be used to be solve both classification and regression problems. Example of the KNN. Imagine a computer is a child. We or its supervised like a parents, guardian or teacher, and we want to build a computer to learn what a dog looks like. We will show the child several different pictures, like some of which are dogs, and the nearest could be picture of anything, cats, horse, etc. When we see a dog, we should dog. When it's not a dog, we should not not dog. After doing this several times with the child, we show them a picture and ask dog, and they will correctly most of the time say dog or not dog, depending on what the picture is. What is supervised machine learning? The dog versus cats database is a standard computer vision database that involves classifying photos as either containing a dog or cat. Although the problem sounds simple, and now we can see it was only effective addressed in the last few years. While the database is effectively solved, it can be used as a basic of learning and practicing how to develop evaluate classification from and now this includes how to develop a robust test harness for estimating the performance of the model, how to explore the improvements to the model, and how to save the model and later load it to make predictions on new data. There are some more examples. The dataset is comprised of photos of dogs and cats, provide as a subset of photos from much larger dataset of 20,000 images. Dataset dogs versus cats description binary classification classified dogs and cats training 20,000 images as per class 10,000 validation 5,000 images 2,500 per class testing 12,500 unlabeled images. And now we will talk about the code explanation. Generate data generator with method image data generator and giving argument. You can see in the code explanation training dataset, training data generator, image data generator. There is a recall is equal to 1 over 2 double five. aperture range, zoom range, and horizontal flip. Validation data generator, image data generator, recall, and no test data generator, image data generator, again recall, no preparing data, get the image from training generator, validate generator, test the generator, training generator. In the code explanation, training data generator flow from directory, training data directory. Now the validation generator, you can see the code which validation data, target size, batch size, class mode, test generator flow from directory, test data directory, target size, batch size, class mode, and shuffle is equal faster to. Now in the code explanation, model fit generator set the batch size with like step per approach, validation, data testing, open the test file, plot the title and probability of detecting dog or cat. In the training, you can see in the code section model.fit generator. In this section, training generator set per approach code is like approaches, validation data, validation steps, and callbacks. Here is the code which is implemented and classify the deep learning testing. Now testing session, open test, and probabilities for index, probability in image batch, image with open, and plot, and if probability is greater than 0.5, so title probability is 0 multiplied by 100 plus dog title. And on the next slide, model 1 conv 2D and flatten the image, then 16 dropout 0.5 activation, it's not bad. We will validation accuracy at 77.5%, means it collect identify 77.5% of the objects. Model 1, you can see the model 1 sequential, model 1 add activation, model 1 add max pooling, pool size, and activation max pooling again. And in this bottom you can see model 1 in training session. This is a graph, you can see the performance, and this is the model 1 validation, which shows the values in the graph in the horizontal or in model 2. Flatten the images, dance with 125 to output 0.5, dance activation, model to increased the validation accuracy 85%. Here you can see uh, model 1 correctly identifies 77.5% of the object. Model 2 increased the validation accuracy 85%. You can see the code, and here is a graph. Model 1 training, model 1 validation, which is show the performance. And now model 2, we will talk about the results. It detects first cat 99.96%, second dog 99.9591%, third dog 99.90%, fourth dog 100% cat, fifth dog 92.81%, sixth dog 92.81%, seventh dog 100%, eighth dog 100%, ninth cat 100%. You can see the pictures which shows detection values in the model 2, and these are the results which we have to find. And now, thank you everyone. Goodbye.